the changes made to the Java language in recent releases, it has moved into a new realm, data-oriented programming. In this talk, our speaker will explain what data-oriented programming is, and the principles it is based upon. For more than 15 years, our speaker has been working on the JVM and the Java ecosystem. He is an Oracle certified Java programmer and Sun certified business component developer. Let's show some love to Team Rockstar's IT special agent, Mr. Ron Veen.
Hello everyone. I hope you can hear me. I'm very excited to be here actually, and I'm really sorry I couldn't be there with you guys in Manila. I think it would have been a dream, but it just didn't fit in the schedule. So it's still great that we can do things like this. So just let me start my presentation for you. And then I guess it's time to get started about data-oriented programming in Java. So if there's any questions, I think it's way easier if you just ask them in the app, and then you'll have a look at them afterwards, after the presentation. Right, data-oriented programming in Java. Just a few things about myself. Like you already heard, I'm a Java developer. I work at Team Rockstars IT in the Netherlands. As a special agent, which means we get to go to conferences like these. Well, normally we get to go. And for the last year, I've been having this text here saying, I am writing a book about migrating to cloud-native Jakarta EE. The good thing, however, is that I can say the book is finally completed. So it will be published by the end of this month. So I'm really excited about it. In case you want to have a sneak peek, this is the link to the Amazon page where the book can be pre-ordered. Right. So what is this data-oriented programming? In June 2022, Brian Getz, the Java language architect, he started a post in InfoQ where he wrote about data-oriented programming in Java. Java has had many projects to increase the language, improve the language. One of them was Project Ember. And Ember had a lot of small changes, which we will look at later, that actually provided these possibilities to do data-oriented programming. A very interesting article in the resources attached to this talk. All the links to the things I mentioned here are attached, so you can actually read them for yourself. There's the Java podcast on YouTube, and Nikolai Parler had a great article there, a great session about data-oriented programming. And at Java 1 that year, Gavin Bierman, another one from the Oracle team, gave a presentation on data-oriented programming. So clearly something was going on. So let's have a look what this is all about. Our agenda for today is we're first going to look at an evolution of traditional applications. Then I will give a short introduction about what is data-oriented programming all about. Then we're going to look at how Java, with the changes made by Project Ember, is supporting data-oriented programming. And finally, we're going to look at a number of examples of data-oriented programming in real life. So let's start with part one, the evolution of an application. So meet our guy here. He's a developer. He's an internal developer at a company. And he loves this job because he's the one who gets to do the timesheets. So this is his part of the application. And the timesheet application that he develops is quite easy. You know, there's a user attached to a timesheet header, and there's timesheet details, and there's projects and activities, and life is really simple. And he loves working on this thing. Well, all of us probably hate entering timesheets all the time, but he's really in love with it. But then one day, the project manager drops by and says, "Listen, there has to be a problem because there's people that I don't even know in this company that are registering time against my projects. You have to check your code. Something must be wrong." And he looks at the code and he sees, well, that's right. There's no real connection between projects and user, and any user can just write on a project. So he changes the code and makes this connection, and now only users that are actually tied to a project can write code there. And it seems like life is good again. But it doesn't take long until the project manager comes in again and says, "So you fixed the problem from last time, but what about this? Because now I can see that someone who's actually working in front-end design is doing some activities related to API design. So that can't be right." And again, he looks at his code and he says, "Yeah, you're right. There's no link between projects and activities. I can just write on any activity." So he fixes that too. And so the system keeps growing and growing. But not only the system, the company keeps growing. From the few people that work there, it is becoming a really, really big company. So suddenly, the one a regular user is not enough anymore. We have to have different groups of users. We need to have approvers, and we need to have project managers. And it doesn't take long until the company goes multi-company. So we need to have an organization, and then we need extra reports and timesheet invoices. And I think you get the idea here. Always start out with the basic object model, and then the system improves, improves, improves. All of this is in this one gigantic application. Um, some people will use the term monolithic application. I'm just not really happy with that term. So because it sounds like something bad, but it is still one very large application. Um, and so the code that would typically belong to classes that are part of this application would be something like this. Here we have a user bean, and we see some fields that we register from the user: his email, his password, whether he's active, how many login attempts there are. And we can see methods like reset, deactivate user, register failed, login. These are methods that act upon the data that is stored in this class. So this is the typical case of encapsulation in Java, where we have data and methods acting on that data. But if we look at this monolithic application, then we can actually see that there's different domains in there. And I'm quite sure that all of you have realized that since like a few years, there's this idea going on of creating smaller applications. We're applying domain-driven design to see where the bounded context of our system is, where are the separate subsystems, if you will, and create separate applications or microservices for them. So here we have a user domain, but there's also the timesheet domain. There's domain core data that contains all the core data files for this project. There's an authorization domain, and so the application gets decomposed into different parts that do interact with each other, but not so much as they would do in this gigantic application that we had. So Brian Getz, when he wrote this article about data-oriented programming, he said, well, Java has changed. It is not just only object-oriented programming anymore with these enormous data structures. we now see, we tend to see smaller programs, like we said, microservices or mini services, and they don't require this complete object model anymore. And if this object model and the relationships are not maintained like that anymore, then maybe data oriented programming could be a really good approach. So, what are the principles of data oriented programming? We'll first go through them and then we'll dive into a bit more detail. It is the separation from data and logic. It is that data should be stored in generic data structures. The data should be immutable. And if we look at a bit more detail into these three parts, then we can see separate logic from data. So before we saw this bean there, and there we said, oh wait, we have data and we have code operating on that data. Well, here we're actually saying, no, we should split it. We should split this object tree. We take the data out of the object that is acting upon it. So we have a data object and we have a logic object. One of the advantages would be that we can actually reuse it in different contexts. If you take the example above, where we saw the user being, we saw we had three different types of users. We had the regular user, the approver, and the project manager. Now, if you would write any good design, then probably you would have a base class where all this login code that we saw before would be modeled, and then these three types would inherit from it. Um, but you could also have a situation here, and that's where we separate the context, where you have one bean that can do all this logic and they just send it a user bean of any type and it can act upon that. So that's the idea. You can reuse it in different contexts. Testing in isolation makes it a bit more easier. If you have to create this bean with initial state and methods acting upon that state, that's way more complicated than when you can just create a user object with its properties and pass it on to a method for testing. In general, when we break the object hierarchy that we just saw, we tend to get less complicated systems because all the interactions between classes is way more simple. And then we said data should be stored in generic data structures. Well, what are generic data structures? Well, in Java, they could be like maps or lists or even queues for all I care. And they allow for a flexible data model. Imagine that you would have your user object stored in a hash map where the field name would be the key and the actual value would be the value. Adding a field to such a structure would, of course, be really, really simple compared to when you add it to a class and then to other structures. And we could then also develop generic functions that are not limited to the scope of our data classes. Because in general, if everything is a map, then suddenly a method that you have, well, it can take a map and it can perform an operation. Whilst if you would put in a user or a project, it would not be so easy because it can only work on these generic properties that they would have. Data should be immutable. Well, why do we want immutability? Of course, immutability gives us a certain kind of safety and reasoning about data in a project. It doesn't mean that data can never change. The reference to the data may change. The actual values will always stay the same. So if you want to change the data, what you actually do is that you return a new object with different values. So the data itself is immutable, but of course, data always needs to change. This gives you predictable behavior because certainly instead of your data being able to change everywhere in your application, you now know there's a few predefined places where that will actually happen. And finally, it will enable safer concurrency. When you have multiple threads accessing your data, but this data cannot be changed by these threads, then you will never have erase conditions and your code will be more stable. So we've now seen a bit of what data-oriented is all about. So let's now have a look at how does Java support data-oriented programming. We're going to look at a few things. We're going to look at records, sealed classes, pattern matching in general, and switch functions for pattern matching. These were four things which were brought to the Java language by Project Ember, and we're going to look at them in a bit more detail. Um, Normally at this point, when I would actually see the real audience, I would ask them, okay, who's familiar with records? And then we would either dive in deeply or not so deep. In this case, I'm just going to assume we're all starting on a blank page. So records. Records are small data carriers, immutable data carriers. That's an important addition. They were introduced, top of my head, somewhere in Java 14 or 15. And they're really just a specialized form of a class. You define them by using the keyword record, like here, public record. Then you name the record, and then, in contrast to how you define classes, then here you define the type and the name of all the instance variables of your record. Now, it is a good thing to notice that these instance variables, they're actually final instance variables. In Java, that means that once the constructor completes, these instance variables will have their final value and they cannot be changed anymore. So here we're defining a record, user record, with four properties: email, password, and a boolean is blocked, and an integer for login attempts. And that's all you need. No more code is required. Now, if you would like to test the values that are coming in, because these are the parameters coming in into your application, you can override the constructor. And records have a special form of a constructor, which is called the compact constructor, and it looks like this. You basically just define public in the name of your record, and you don't have to tell it what are all the parameters because the compiler already knows. You define it up there, and as we said, you need to have a value for all these variables once the constructor completes. The constructor knows you will pass in all four of these values. So in this compact constructor, you can do your testing of the values coming in and to see if you can create a valid state. So the require non-null on email will throw an exception if the email is actually null, and it will prevent the record from being created, which is very important because this means that you can never create illegal state. Now, all the fields that we see here, email, password, and login attempts, they're actually the parameters coming in, the values for the parameters. They're not the actual instance variables. Once the last line of the constructor is executed and no exception has been thrown, then a compiler will automatically insert code that will take these parameters and assign their values to the instance variables. So it's very little code for a lot of functionality. Of course, you get a lot of extra methods as well. You get the getters that are automatically generated for you, the equals, the hash code, the toString, all those things. Creating a record is as simple as creating any other class. You simply specify the new keyword and provide all the constructor values, so the parameters. So in this case, we provide the four values. Now, I already said that records are immutable, so that means we don't have the classical set methods to set new values. In fact, we don't even have the classical Java bean convention getter methods. If you want to retrieve the value from one of these variables, you simply use their name. So instead of get email like we know from the classes in Java, we simply can use this. Another change to Java was adding sealed classes. And sealed classes is all about object inheritance and hierarchy. So if you define a class in Java, you basically have two options um, about inheritance. Either you say, well, I'm going to make a public class, and then anyone that has access to this class can inherit from it and create subclasses from it. Or you choose to say, no, I'll make this class final. And then no one at all can subclass your class. A great example of this, of course, is the string class in Java, which is a final class, and you cannot create subclasses of string class. And there's good reason for that, of course, because basically we don't want you to change behavior of methods in those system classes. Because if you suddenly decide that the toString is not, or the to upper is going to do something completely different than converting it to uppercase, then it can really undermine the predictability of the application. So we have these two things, right? We either or everyone or no one. And of course, you could say, well, I can do something with package visibility and stuff like that. In general, yes, but it is still all or nothing. Well, sealed classes are different. If we look at an example here, and everywhere where I say sealed class, you can also read sealed interface because the rules apply to both classes and interfaces. I'm defining a sealed interface user here. So I'm saying, okay, this is a tight group. This class is special because not anyone is allowed to inherit from it. And the classes that are named here after the permits clause. So approver, project manager, and a regular user, they are allowed to subclass, or in this case, implement user. If any other class would try, then the compiler will say, sorry, there's a stricter access rule and you're not on the list. So you're not invited. You can't do this. Now, all of these classes that are permitted to subclass, they themselves have to specify how they will handle inheritance from their part. And there's three possible ways. So the most obvious one is that in this case, approver, he is specified as a sealed class. And he says, yes, I'm implementing user and I'm allowing two other classes, timesheet approver and invoice approver, to subclass for me. So it basically uses the same rules. It says permits again. The second option is that you say, no, wait, this, it stops here, right? Public class final project manager. So I'm marking this class as final. As you can see, the sealed keyword is no longer required then, but now it's the final keyword. And that means no one can inherit. So this is actually the basic behavior that we know from Java classes if you define a final class. And thirdly, there's the option to declare the class non-sealed. So this might seem strange at first, because now you say, well, regular user, I'm implementing user, so I'm in this strict hierarchy of who is allowed to inherit, and then I'm probably suddenly declaring myself, oh no, but I'm non-sealed, so I don't care. Anyone can inherit from me. Well, this might seem strange because suddenly it seems that this carefully crafted inheritance tree is completely thrown away. But basically, it's not like that because the compiler can still reason, and it will do so later when we get to that part. The compiler can reason that Regular user, well, everyone inheriting from regular user is still a regular user. It will be an instance of a regular user, which is really important for the compiler to know, which we'll see later. The third new thing that was added to the Java language was pattern matching. And in pattern matching, basically, we have a few things. We have a predicate or a test, an object to test against. We have pattern variables. Once a test is successfully executed, we can extract some values there, which are called the pattern variables. And these pattern variables are in a special scope called a flow scope. Now, let's have a look at an example. If we have this method here, we say public static boolean allow approving passing in a user object. And then we return the boolean value that comes from the test user instance of approver. And then we see A. Now, this is not your regular instance of that you know from Java since the beginning, but this is an instance of pattern matching expression. If we look at detail, the predicate here is actually instance of approver. That is the test we're going to execute. And we're going to execute this test against the user object. And wasn't this test successful? If this user object turns out to be an instance of the approver class, then it is extracted into a pattern variable, which is A. And as you can see now, A is an instance of user, but it is cast to the approver type. So A can access all the methods and properties of an approver. And the flow scope basically means that A only exists between the curly brackets here. After the return, it won't be accessible anymore. So instance of was the first pattern added to Java, and it was in Java 17. But pattern matching didn't stop there. We later got pattern matching for switch. And if we look at this same example, public static boolean allow approving and passing in a user object again, now you can actually see that we're switching over this user object being passed in, and we start to reason about what the code should do based on the type of class or record being passed in. And this is where you get into the realm of data-oriented programming, because now suddenly the type of classes, whether they are an approver or a project manager or a regular user, defines the outcome of this method, and it determines if someone is allowed to do approving or not. It could be very much normally in a situation where on a user you would have a property saying is allowed for approving or something, but no, now we're saying here, no, this is different. We're crafting our object model, and now we're determining which ones are allowed to do certain things based on their name. So this is the part where data has been lifted and becomes a first-class citizen. So if we take a look at this example, we can actually see case approver, and then we see the pattern matching and that it extracts the variable in A. Now we could have used A here. In this case, we're not using it. So we're just returning true based on knowing that you are a class approver. We know you can do certain things. For project manager and regular user, they're not allowed to do approving, so they will return false. But then we'll have this situation, because Java 17 also introduced a guarded pattern. And if you look at the first case statement again, you can actually see case approver A, where A dot is active. So the guarded pattern is that it says, yes, I'm deciding to do some action based on the name approver, but only under a certain condition. So the interesting part here is we get case approver A. So A is extracted into the pattern variable, and then directly after the when we can already use this pattern variable and call methods on it. Now, normally, if I would actually see the audience and stand on the stage, I would ask the question, so why is there the second line? There's another line with approver A in there. So why is that? And it's a tricky situation. But if you look at the switch statements, you can see there is no default case. And normally, we would have a default case, right? Because if you have to be exhaustive in switches, and if you're not, then you have to have the default case, so the compiler knows which code to execute in case none of the cases actually apply. But we didn't see that, not at the first example that we did, and not here. So the reason for that is that we're working with sealed classes, and the compiler knows, oh, wait a minute, if you're passing in a user, then I know that only approver, project manager, and regular user are instances of user. So you listed them all. Good, I'm happy. But if I would leave out the second case with just case approver A, that would mean that I would skip all those situations where we do get an approver, but is active is false. And then the compiler would say, oh, you're not covering all the bases, mate. So I can't accept it either. You have to insert approver again, and I'll handle the rest for them, or you have to add the default. So that's why the second approver line is in there. We just saw that records were being added to the Java language, and now here we can actually see pattern matching for record. That was also being added. It started off with instance of, which we already seen before. So if we pass a user record here, then we can call a method on it, one on its pattern variable. But it got even a bit better, because we got to switch over these records, and we got record deconstructors. Now this is the interesting part. Let's look at the switch record. The first thing we see, the case null. That's an interesting one, because normally in switch, when switch was still only a statement and not a function like here, then you always had to do the null pointer test first. Test if record not is null, then you could enter the switch. Otherwise, you would probably get a null pointer exception. Well, they saw that problem, and they thought they would fix it along the way. So they said, no, we now allow you to do a case null. So if the record that comes in here is null, it will be handled by that case. But then the next one is really interesting. Case user record. And it almost looks like we're defining that record again here, but it's actually not the case. What we are doing here is that we are deconstructing the user record, where a constructor takes parameters and creates an object. A deconstructor takes an object and assigns its instance variables to local variables. So what we see here with string E, string P, boolean B, and int A, they are local variables, and they can assign the values from the instance variables of the record being passed in. So in the system out print line, you can actually see that I'm using those values, E and B in this case, to print the values. So I don't have to say record.email or record.blocked, but I can use these local variables now. And that even went a bit further in the next Java version, because where we still had to define at first here user record with the specific types, a later version said, wait, the compiler can infer the types for us. It knows that email is a string, and it knows that attempts is an integer. So we could use the local variable definition keyword var here. So we can now say var e, var p, var b, and var a. But it didn't even stop there. With Java 21, we actually had the unnamed variable changed, introduced now. So I'm only using in my system out print line, only using the variables E and B. So why would I define the others? So now it is possible to say that if you don't care about a variable, you can just pass in the underscore, and you're saying, I know there's a variable in this place. I just don't care about its value, so I don't even need a name for it. So now I only have E and B, and the other ones are completely not used. Well, that is all quite great. So now we have seen the ways in Project Ember has changed the language and how it can be applied to data-oriented programming. So let's look at some real-world examples of this. Um, just reiterating the principles, we separate the data from logic, we store the data in generic data structures, and the data should be immutable. Just diving in a few details how this could be done in Java. Separating data from logic. This could be done in different ways, and maybe it may sound strange, like you're separating data from logic, but is that really so strange? I bet there's a lot of you listening to this presentation that will program with the Spring framework. And if you do so, then you create your beans. You either annotate them with at service, for instance, and you say, oh, this is a service bean. And those beans are very typically stateless, right? If you want to do some actions on some piece of data, probably a method in that bean is being called and it gets passed in the data as a parameter. If there's some of you out there that actually use Java EE or Jakarta EE, then you have enterprise Java beans or Java beans. And enterprise Java beans, there's several flavors of them, but one of them is the stateless session bean. So basically, the name already implies that it has no state. It just performs operation on some piece of data that it receives as a parameter. So separating data from logic, even though it sounds strange and counter OOP, it is something we already do a lot in our coding. Brian Getz in his article says, well, we could also do it with static methods. Again, this must hurt our feeling as object-oriented developers, but there's nothing wrong with static methods. And like I said, it's not that different from how we use beans in Jakarta EE and in Spring. So, storing data in generic data structures. How could that work in Java? Well, since Java 9, we have this great map of list of functions, these where we can initialize a map or a list with an initial value. So in this case, we're creating a map here where the keys are email, password, blocked, and attempt. And to each key, there is a value. Email, password is blocked, and login attempts coming from the user object. Now, if you want to retrieve these values, you could do something like this to get the user email. You're passing in the map and a value, and then you say, oh yeah, I think I want the value from the map where the key equals to email. So you see, we have to do casting and stuff like that. Doesn't look really good. And I think we just saw that Java maybe has a better approach to a generic data structure than using these ones. Another really bad part from this is, of course, that we completely would give up on all the type checking that the compiler provides for us. So records would be a way better solution, especially because we said data should be immutable. Well, that's really handy because records turn out to be immutable. So we can separate our data from logic. We can do immutable data, and we're not using generic data structures, but records, well, they're generic data carriers, so they come quite close. So let's look at implementation of data-oriented programming. So we have here this sealed interface opt. As you all know, since Java 8, we have the optional class. And the optional class basically says, okay, it's a kind of Schrodinger's cat situation. Um, there could be a value in the optional, there couldn't be a value in the optional. You don't know, it could be either. And unless you ask, you will find out. So, and Brian Getz in this article says from, well, if by the time we added optional to Java language, had all these things from Project Ember in place, we probably would have designed it differently. We would have designed it like we see here. We would have designed a sealed interface of a generic type T. So generic type T means it can contain any type of object. And if one of the things is that we want to have immutable state to be not only immutable, but also valid, always valid, we'll define two possible outcomes for an interface opt. In this case, it could either be that it will return a record sum with a value because it contains a value, or in case the optional doesn't contain a value, it will just return an empty none value. So as you can see, these records, as they are defined inside the sealed interface, and they say they implement the interface, which isn't even required here, these are the only two possible subclasses that are allowed for the interface opt. And if we would look at code in an example program, it would actually look like this. If we would have the public static void main, we would create a new instance of our class, call the run method with the command line arguments. Then in the run method, we would do a validate first, which would return a value to us, and that value is used in the process method. And let's look at the implementations of these two methods. So the ops string validate method, it gets the command line parameters in. So it checks, is there a command line parameter? If the length of the parameters is 0, meaning no command line parameter, I'm just returning opt none. Now, if there is a parameter, I'm returning an instance of opt sum and returning the first parameter of the command line. And then the process value, and this is where it's all about. The process value knows it's getting in an optional, and an optional can only have two possible outcomes ever. Either it is sum or it is none, but there is no other state possible. So you can really define very easily and closely what you want to do, and it's very easy through the application, and it makes very clear, okay, I'm getting an optional, in this case sum. If there's a value, I'm doing this. If there's no value, I'm doing that. So the rules of data-oriented programming really are: model the data as data, the data should be immutable, validate at the boundary. So that's what we did here, right? We validated here, the data came in, and we said, okay, if there's a parameter, then we return some, otherwise we will return none. And you make illegal states unrepresentable. And just to make these two last things even more clearer, let's look at another example. Let's look at the sealed interface search results. So we have this generic search function, and it could be for a project, it could be for a use, it could be for anything. And your search can deliver three possible outcomes here. It can say, oh, we didn't find anything that we searched for, so no result. Or you searched for the project ID and you got an exact result. Or finally, there is the options that you search for a project description. So you could get a list, more than one result, which would return a multi-result. Now, assuming that we have a very simple search method here, we're saying find projects with a search key, and we're returning some kind of exact result here, just for example reasons. Then in our processing code, it would actually look like this. We would have the magic method search, passing in a value, then we return the result of the service find projects. So that's the actual search thing. And then we know that this search can only ever have three possible outcomes. So we know it will be a no result, an exact result, or multi-result. But again, there's no other state possible. Illegal states can't be represented. So that's an important thing to realize. And then we're going to look at one final example where this illegal state comes in quite easily, because we're imagining you have a REST API, which would be a typical use case for records. You have a REST API and the data comes in the body of this REST post method as a JSON payload. So you take out the JSON and you try to make an object out of it. And if it doesn't work, it will get null and thus unrepresentable. So let's look at this example. We're creating some master data object here where we first do a validate, and after the validate is successful, we'll do a store. So we're modeling it like this. We say sealed interface master data, and now you see actually that I'm permitting here the different types and I'm defining them separately. So both methods are okay. In this case, because I'm defining them separately, I have to use the implements clause. So I'm defining the three subtypes that are possible here. So in this create method, there's the validate method. And the validate method, it gets the data. And it says, okay, is it case null? And it will be case null if your data came in and the JSON from which it should create the data was invalid. It will return false. And otherwise, oh, well, then we have a valid object and we can validate against it. So we can call the specific validate code. And then the actually store operation already knows that my object will never be null. That has been taken care of. And then it can, again, based on the name, drive the way that the data flows through the application. So that's the real big point here. The data flows through the application. And I know we are really smart programmers and we really think hard about our code. And we try to do really smart things, but we never think about the poor people that come after us and have to read our code, and code is way often read compared to written. And this really gives you a very clean, already almost explanation of what is happening in a code. So to summarize, data-oriented programming treats data as first-class citizens. The data drives your application. Really, it flows through your application and it lets you make decisions based on the data and not so much the data in the data. And Java supports data-oriented programming via records, sealed classes, and pattern matching. And I think we now have 5 minutes to spare for questions.
All right, sir. I think we had one question earlier. Thank you so much for your presentation. There you go. We've flashed it on the screen. So from Jervin Guevara, from Page Up, if we use the same data model across different contexts, would this be in conflict with DDD since we're crossing boundaries yet not translating them to what makes sense for that particular context? I think There's a follow up to this question. He also mentioned, or are data oriented programming and DDD mutually exclusive?
Oh, very good question, Gervin. Yes, no, maybe I wasn't completely clear, but you're completely right. Of course, you shouldn't use the same model in different contexts because uh, a customer, or let's say a manager in one context could mean something completely different than in a different context, would probably have, based on DDD, have different values. So no, but the idea is that you would create these models and you would create smaller applications. You wouldn't reuse them because very likely there would be different projects anyway. So no, no reuse across models. And so it's not in conflict with DDD. Actually, I would say that data-oriented programming and DDD are a perfect match. Um, so no reuse. Maybe I didn't make that clear. Sorry for that, but you're very right.
Thank you, sir, for answering that question. There's another question on screen from Jojo Paderes. Most Java projects are using ORM JPA frameworks like Hibernate. Is the data oriented programming approaches shown from this presentation be used also for these frameworks?
Yeah, another great question because um, I think Joselito touches on a difficult point here because if we look at JPA, the JPA specification says that a record or a class should be annotated with at entity, and it should support a no argument constructor. And we just saw that the records actually require all the parameters in the constructor. So unfortunately, records and JPA, they're mutually exclusive. Then you would have to do something, but J records are really not meant for that. So records are data carriers through your application. So I would suggest getting at the API border where the data comes in, turn it into a record, use it in your application logic, and then somehow migrate that in the end, create your entity objects, have them updated from the record. But you can't use records with JPA unless you can do it if you want to query, because then it's possible to do projections and you can do projections against the record. But updating and such does not work. No.
All right. Any other questions from our audience? We still have a couple of minutes for a couple more questions. You may,
Otherwise,
but I think it's clear. Did you find everything clear already from Sir Ron's presentation? Oh, I there's another question here from Jed Aliado. Is this basically state management?
um, well, we said before. Great question. Have to think about it. Well, yes, records contain state. They do contain state in your application, of course, because at some point we have to realize that we need to somehow keep the information from a customer or a product or a sales order. We have to keep it somewhere, and records would be a perfect place because they're so lightweight and transfer information. I wouldn't call them the state management. I would still say that the entity objects in your applications, there are the real state. These are just, well, like I say, transparent data carriers that can supply changes to your state, uh, but they're not the state management themselves. I hope that was in any way
I hope
clear.
that
So,
answered your question, Jed. Or if not, you could still ask further.
yeah.
All right, another question from, I hope I'm pronouncing this correct, from Tijan Oy from the XC Technology. Might not be related, but can this be an alternative to pandas in Python?
Oh, I think you got me now, Tijan, because I've came across a number of books where they said, "Oh, pandas here and pandas there," and I thought, okay, that's not just only a very cute name, but I really should dive into that. But I am completely unfamiliar with what pandas in Python actually do, so I'm afraid I can't answer that question. But oh, you give me something to dive into today.
Yes, sir. I think you can look on that further after this session. But any more questions, or is everything clear with everyone? Uh, So think I
Also,
think
yeah, sorry, yeah. So, like I said, I uploaded a few resources based on data oriented programming for anyone who wants to have more background. It is really
yeah.
interesting. I should also point out that Nicola Parlo, he's from the Java podcast, he also did some presentations on data oriented programming with a different approach, with an example. So, maybe they're worth looking at as well. You should find them on YouTube.
Mm. All right. So I hope you have taken note of those resources, and I think, if I'm not mistaken, Sir Ron uploaded the resources also here
Correct.
on our Meet, so you can access that simply by going to the resources tab. And I think that's all for the questions today. Thank you so much again, Sir Ron, for answering the
You're
questions.
welcome.
Now, in case, guys, you still have further questions that you might think after the session, feel free to chat with our speaker here on AirMeet. But for now, that's all the time we have for this session. Again, let's thank Sir Ron Veen by showering him with heart or clapping emojis on screen. Thank you again, Sir Ron.
Well, thank
Thank you
you.
so much. Now, may I request everyone to please exit this session and click on your next preferred session, as I think they are already preparing for the following sessions. All right. See you, everyone. See you in the next sessions.